Hey guys, welcome again to the Maths Club. We're going to continue on our series that we started a while ago on sequence and series. And this time around, we're looking at the sum of a geometric series. So if you're just watching, please go back to the playlist on sequence and series and really start from the beginning to enjoy all of the things we've been doing. So what's a geometric series? The expression below represents a general geometric series where the terms are added. So if you look at it, we have Sn is equal to A plus AR, which will be the second term, plus AR squared, which will be the third term, right? Plus the last term will be ARn minus 1. We agree. So if it's 5 terms, that is, if our n is 5, our AR will be 5 minus 1, which is AR4. The last value will be AR4. Second to last value will be AR3. Right? So this is the general form of geometric series. So the A is the first term, the R is the common ratio, the N is the number of terms. So the formula for sum of n terms, when we have the first term, the common ratio, and then the number of terms, we can actually find the sum of any n term. So what's the formula? Formula is saying that we multiply the A by 1 minus R raised to the power of n all over 1 minus R, where the R is less than 1, right? Because if the R is greater than 1, in this place here, like if my R was 2, I will have 1 minus 2 and that'll give me minus 1. So just to avoid that minus part, right? So if the R is less than 1, use this formula. But if the R is greater than 1, we swap the position of the Rn and the 1. You can see it. So this is A Rn minus 1 all over R minus 1. But in this case, where R is greater than 1. So if any of these formulas is looking very strange, how did they come about it? I would show the proof of the formula in the description. So you can look at the description of this particular video. You see a file that contains the proof of these formulas. Now let's look at some examples that would further consolidate all the things that we have been saying and would show us how to actually use these formulas. The first of them says that find the sum of the first 5 terms of the GP 2, 6, 18. So what do we know in this particular question? What are we given? We're told to find the sum of the first 5 terms. So that means our n is equal to 5, right? So we're told the GP is 2, 6. We know that our I is equal to 2. Our R, what is our R? Our R can be 2 divided by T1 or T3 divided by T2, since it's a common ratio. So let's say T3 divided by T2. And that will give me 18 divided by 6, and that is equal to 3. So I have all of these guys. Now our R here is greater than 1. So the formula that we're going to use is Sn is equal to A R raised to the power of n minus 1 all over R minus 1. And if we substitute, our A is 2, so this 2 times R raised to the power of n is what? That will be 3 raised to the power of 5 minus 1 all over 3 minus 1. So let's simplify. So that will be 2 times 3 raised to the power of 5. If you press on your calculator, that will give you 243 minus 1 all over 3 minus 1. That will give you 2, right? So you can see this is multiplication. So I can actually say 2 cancel 2 here, really, right? Since the multiplication that is joining these two guys at the top. So 2 for 3 minus 1, that will give me 242. Let's see if our answer is actually very correct. Great. So our answer is 242. Next question says that we should find the sum of the first 5 terms of the GP 39, 19 and a half, 19, 3 over 4, etc. So similarly here, what are we given? We are given the n to be equal to 5. Do you want to pause the video and find the R? Welcome back. Let's solve it together. So the R is equal to, let me use T2 divided by T1. So that would be 19 and a half divided by 39. So 19 and a half, 2 times 19 is what? Is 38. 38 plus 1 is 39. So 39 divided by 2 multiplied by this 39 will cause, so that will be 1 over 39. So if I cancel out, you see that the ratio is just 1 over 2, right? And then we know our A to be equal to 39, right? So I want you to pause the video and find out what the sum of the first 5 terms would be. Welcome back. Let's solve it together. So we know that the R is less than 1, right? We know that. So that means our formula for Sn will be equal to A 1 minus R raised to the power of n all over 1 minus R. So our A is 39. 1 minus our R is 1 over 2. Our N is 5. So that's 1 over 2 raised to the power of 5 all over 1 minus 1 over 2. So let's substitute. So this will be 39 times 1 minus half raised to the power of 5 is 1 raised to the power of 5 is 1 all over 2 raised to the power of 5 is 32, right? So if I divide this, 1 minus half, right? So you have a full thing, you are taking half of it. Of course, also remain will be half. So let's see. So 39 times, so we have 1 minus 1 over 32. So this one is representing something whole. Let's say you divide a pizza into 32 parts, right? And somebody takes 1 out of the 32 parts, right? So if you subtract it from the whole, how many pizza parts will remain? Of course, it's going to be 31, right? 31 over 32, right? I could do this easily because of it was 1, so I'm using this 1 as like an whole number, like the whole parts, right? So if it's number 5, it might not be that easy, right? When it's 1, it's always very easy like that. So divided by 1 over 2, right? So 39 times 31, right? So if you do that on your calculator, that will give you 1209 divided by 32, right? So divided by 1 over 2. So let's finish this up. So this will be 1209 over 32 times, so this 2 will come over, so that will be 2 over 1. So 2 here 1, 2 here 16. So we have 1209 divided by 16. So if I divide 1209 divided by 16, I will have, so the whole number part is 75, right? So that the whole number part is 75, right? So if I want to find the, so if I do 75, that we got times 16. So this base here, I'm saying 75 times 16, that gave me 1200. So that means at the end of the day there was 9 remaining. There was 9 remaining. So that would be 75 9 over 16. What did I do? I did 1209 divided by 16, that's 75, right? That was the whole number part, 75 point something. So I took that whole number part, I multiplied it by 16. Let me see what it gave me, right? So it gave me 1002. That means that there was 9 remaining. So that's, I said, 9 over, right, 16. So let's see if our answer is actually correct. Great. So we have 75 9 over 16. Question 3 says, if the second and fifth term of the GP are -6 and 48 respectively, find the sum of the first 4 terms. So what are we given? We're told that T2 is equal to -6 and T5 is equal to 48. And we're told to find the sum of the first 4 terms. Great. So T2 is the same thing as saying AR, right? So let's say this is equal to -6. And T5 is the same thing as saying AR what? Great. AR is to the power of 4, which is equal to 48. So if I say this is my equation 1 and this is my equation 2, because there's multiplication joining them, right? I have to divide. So if I say equation 2 divided by equation 1, I have a feeling that by the time we reach simultaneous equation, it's very, very easy, because we've actually been dealing with simultaneous equation really, really well. And I would have loved us to have done simultaneous equation first, but we're trying to follow the WAEC syllabus. So this guy divided by this guy, this will be AR raised to the power of 4 divided by AR is equal to, this guy divided by this guy, this will be 48 divided by -6. So A will cancel A. If you have R times R times R times R, and you have so R here will cancel one of these R's, so that will be R cubed. So what I will have here will be R cubed is equal to 48 divided by -6. That will give you -8. So to find R, we take the cube root of both sides. So taking cube roots of both sides, so that will be cube root of R cube is equal to cube root of -8. So cube root of R cube will give you R, really. So cube root of what's something that you multiply 3 times that will give you -8? So let's see. If I say -2 times -2, so that will give you 4, because minus is plus. If I multiply that 4 again by -2, that will give me -8, right? So that means that our R is equal to -2, right? Because the cube of -8 is -2. Now we know the R, right? The other thing that we need for us to find the sum, we need our A. So if I take this equation 1, right, which is AR is equal to 6. So if I say from equation 1, AR is equal to, is it -6 or 6? Let me see. Is equal to -6. So AR is equal to -6. So that will be 8 times -2 is equal to -6. If I divide both sides by minus 2, this will cancel this. Minus will cancel minus 2 here 1, 2 here 3. Right, so my A is equal to 3. Now that I know my A and I know my R, I can be able to find the formula or the sum of the first 4 terms, if I'm correct here, first 4 terms. So we know our R. Our R is less than 1. So our formula is going to be A open brackets 1 minus R raised to the power of n all over 1 minus R. So this is the sum of n. So that means the sum of the first 4 will be our A is 3, so that is 3 times 1 minus our R is minus 2, so that will be minus 2 raised to the power of 4 all over 1 minus 2. So this is 3 times, so 1 minus 2 raised to the power of 4, that will give you 16 all over 1 minus, that will be 1 plus 2, right? So let's simplify this. This will give me 3 times 1 minus 16 is going to be minus 15 all over 1 plus 2 is going to be 3. So if I mean this is multiplication, so if I cancel out 3 here 1, 3 here 1, I'll be left with 1 times minus 15, which is equal to minus 15. So let's see if our answer is actually correct. Great, so our answer is minus 15. Well done, everyone. So now we're looking at formula for sum to infinity. It says a GP whose common ratio is between minus 1 and plus 1. An example is minus 1 over 2, 1 over 4, 3 over 4, 4 over 5, things like that. They have a sum which approaches a finite value, right? Which approaches a value that would not change as n approaches infinity. I know that is a bit of English, so let's look at it in mathematical terms. So our formula is Sn is equal to, because the value of the R is less than 1, so I'm going to use 1 minus R raised to the power of n all over 1 minus R. What happens when, let's say, R is equal to half, right? If n is equal to, let's say, 2, right? Our R raised to the power of n, so that will be 1 over 2 raised to the power of 2, and that will be 1 over 4, right? If our n is equal to 500, right? What is our R raised to the power of n? Our R raised to the power of n will be 1 over 2 raised to the power of 500. So put that in your calculator. So 1 over 2 raised to the power of 500, that will give you 0. Look at something too. So we move from number 2, which is a small value, to a very high value, 500. If my n is equal to 10,000, very large, what will be my R raised to the power of n? My R raised to the power of n will be 1 over 2 raised to the power of 10,000. So if you do that in your calculator, punch it in your calculator, what would that give you? That will give you 0, right? So you notice that when you're dealing with small values of n, the R raised to the power of n will still be a value that you can work with, right? 1 over 4. But when you start reaching very, very, very large values, right? When you're turning to infinity, like 10 billion, all those things, what you notice about the R raised to the power of n, it becomes 0, right? And that is the portion that we're actually interested in. So if this portion R raised to the power of n becomes 0, that means that in this our Sn, what will be having will be 1 minus 0. So okay, so I forgot the a, so there should be an a here. So a open brackets 1 minus 0 all over 1 minus R, right? And this will be like saying a times 1, right? Because 1 minus 0 is 1. I don't like saying a times 1, so that will be a over 1 minus R. So that means that when our n is tending to infinity, a very large value, that means that this thing inside the brackets will be resolved to 1. And if that is the case, we can just say our formula for S tends to infinity, we can say it to be what? A over 1 minus R, because at the end of the day, this 1 minus R raised to the power of n would result to 1. So this is our formula for the sum to infinity. You notice that if my n is 500, right, it is still the same A over 1 minus R, and the A would not change, the R will not change. If my n is 10,000, right, it's still the same formula that we use, right? If my n is 20,000, you can see that it's still the same formula that I would use, meaning that I will be getting the same value every time, because it's going to just be the same A and the same R, right? So regardless of the n, right, I'm always going to get the same value. That's why just most times I said, oh, okay, what is that value that I will get as our equation, as our GP, right, as our GP is tending towards infinity, because it's always going to be the same value, right? So I mean, if the n is 500, the n is not playing any portion in this formula. So as our s is tending to infinity, we'll be getting the same value. So that's why they said that it has a sum which approaches a finite value, right? Which approaches the same value as n approaches infinity, right? So if we want to find the sum of the GP, right, we can just use this particular formula. Let's look at an example that will buttress what we've said. So this example is saying that we should find the sum to infinity of the GP 4, 2, 1. So what are we given? We're told that the A is equal to 4, the R is equal to, so I could say T2 divided by T1, right? So this is like saying 2 over 4, 1 over 2. So we can see our R is within that range. So because we are finding the sum to infinity, as it's tending to infinity, we'll be getting the same value of the sum. What is our sum to infinity formula? A over 1 minus R. Very good. So the A is 4 divided by 1 minus half. And that will be 4 divided by 1 minus half is half, right? So that will be 4 times 2, right? By the time you do all those rigmarole rules, so at the end of the day you have 8. Let's see if we're correct. Great. So our answer is 8. So that brings us to the end of the sum of geometric progression, or the sum of geometric series, right? In the next video we'll be looking at WAEC past questions on AP and GP. Please don't forget to like the video if you found it interesting. If you have any question or any comments, put it down in the comment section. I will answer our questions and spread the word. There's somebody out there that might need this channel, right? A lot of work and investment goes into each video that we make. So subscribe if you're not subscribed and really spread the word. See you guys in the next video.